Hey guys, once again welcome to our channel. So as you can suggest by the video's thumbnail that today we are going to deal with a new concept, that is the methods of purification. And one more thing I would like to tell you, that this would be the last concept of our chapter, experimental techniques. So before moving on, let's just have a glance at the syllabus. So overall, what happened in our previous video, we covered the last part of the criteria of purity, and in today's video what we are going to do, that's the methods of purification. We are going to describe and explain methods of purification by the use of a suitable solvent. We are going to discuss about different methods of purification, that includes filtration, crystallization and distillation, including the use of a fractionating column that we are going to discuss about for simple distillation and fractional distillation. And we are also going to suggest suitable purification techniques given information about the substances involved. And later on in the chapter 14, unit 2 and unit 6, what we are going to do, we are going to discuss fractional distillation of petroleum and products of fermentation. But for now we'll stick to the main topics, the basics of methods of purification. So without wasting our precious time, let us get started. So the choice of the method of separation depends on the nature of substances being separated. All methods rely on there being a difference of some sort, usually in a physical property such as boiling point, between the substances being separated. Now, it's any method. For example, if you're using filtration, you're using decantation, you're using centrifugation, simple distillation, fractional distillation, any method, it will rely, what method we are going to use will depend on the nature of the substances being separated. It will depend on their properties, whether it's a solid, whether it's a liquid, maybe some differences in density or other physical properties such as your boiling point, melting point, between the substances being separated. Now, if you're talking about mixtures of solids, now the main differences that are taken into account are the differences: density, magnetic properties, sublimation and solubility can be used. These are the main differences that can be taken into account. Now, for a difference in solubility, if you are talking about a difference in solubility, now a suitable solvent must be chosen to ensure the desired substance only dissolve in it and not other substances or impurities. Now, for example, if I'm talking about if I'm considering the difference in solubility, I will make sure that a suitable solvent must be chosen so that my desired substance only dissolves in that and not in other substances or impurities. Basically, this will make it a pure substance or an impure substance. So, yeah. Moving on to mixtures of liquids. Now, if I talk about mixtures of liquids, there's one type of liquid called immiscible liquid. What is that? Now, immiscible liquids, these are two or more liquids which do not mix together. They are immiscible, and immiscible means that two or more liquids which do not mix together. If two liquids form two layers, when they are mixed, then they are immiscible. For example, if you want the example in daily lives, what happens when you're using your kerosene and water? What happens if you pour them? For example, if you take maybe a flask, if you pour your water, then you pour your kerosene, what will happen? These two substances will form two layers. They never mix with each other. And why this happens? Because there's a difference. Now, water is a polar molecule and oil is a non-polar molecule. So what will happen? These two will form layers on top of that. Okay, and this usually occurs for polar and non-polar substances, explained already, that's oil and water. So I'm going to show you the diagrammatic representation of that too. So immiscible liquids can be separated by using a separating funnel or by decantation. Pouring carefully, examples include when an organic product is formed in aqueous conditions. Decantation, we are going to discuss that in a moment. So here is a diagram of a separating funnel, and the example is that then I'm pouring my kerosene and water. So firstly I poured my water, then my kerosene, and you can see these are forming two layers. Now what happens if I'm placing a beaker underneath this separating funnel? If I open my stopcock, alright, what happens? The water will flow. When the water will be flown away, what will happen? I'll close my stopcock, and hence I get my kerosene oil and water separated. So this is one of the separation methods of purification, that I'm separating two substances, one of the separation techniques. Moving on. Now we are going to discuss the main methods. Let's come to the main method now. The main concept that we're going to discuss now here is filtration. Now, one more thing, that's filtration. So we have alternative techniques. Compared to filtration, we have filtration, we have centrifugation, we have decantation. They have not mentioned about decantation and centrifugation, but hence we should know some additional information, some extra information about the alternative methods, how they work. So this will make your things a bit easier. So what is filtration? Let's move on to filtration first. Now filtration is a process, is a procedure in which we separate an undissolved solid from a mixture of the solid and a liquid. Now in this case, if we take an example, examples could be sand, from a mixture of sand and water. Centrifugation can also be used for this mixture, and that process we are going to discuss in a moment. Now what happens here? The process is that a filter paper is placed in a filter funnel above another beaker, and a mixture of the insoluble solid and the liquid is poured into the filter funnel. So let me just show you the diagram here. Now you can see here clearly that I have the mixture of the solid and a liquid, and what's happening here, that I am pouring that mixture of solid and liquid, in this case the mixture of sand and water, and I'm trying to separate sand from that water, that undissolved solid from that mixture of sand and water. Now what will happen? Now I will pour, firstly, initially I will pour that into the filter funnel, and here you can see the filter funnel, and there is a filter paper above that filter funnel. What will happen here now? Now filter paper will only allow small liquid particles to pass through as the filtrate. Now what happens? Your filter paper will only allow, it will restrict the movement of the sand particles, and it will only allow the liquid to flow and collected and be collected in the beaker underneath it, that will be called the filtrant. And what will happen, that solid particles, that the two large particles, the two heavy sand particles would be unable to pass through that filter paper, and so will stay behind as a residue. So what happens? Your sand particles get trapped in the filter paper, and they are left behind as a residue. We call this as a residue, and your liquid particles will be able to escape through the filter paper and will be collected in the beaker underneath, and will be defined as a filtrant. All right, and so we have different methods also for this. So different alternatives, that includes your decantation and centrifugation. So what is centrifugation first? Now remember, all of these three methods are used to separate an insoluble solid from a liquid: filtration, centrifugation, and decantation. So filtration already we discussed. Now centrifugation. What is centrifugation? Now centrifugation is a technique which uses a spinning tube. Also, you don't need to, you don't have, you don't need to like have any information about that, but it's okay. As I told before, that it's okay to know some additional information, it's good for you. Centrifugation is a technique which uses a spinning tube. The spinning generates a strong centripetal force which causes denser material, solids, to travel towards the bottom of the centrifuge tube at a faster rate than the normal gravity. And what about decantation? Now decantation is a simple process of letting insoluble solids settle in the liquid before gently pouring it out later. So these are the three methods that we could use to separate an insoluble solid or an undissolved solid from a liquid. Moving on to the next method of purification, the next separation technique, that's crystallization. Now what is crystallization? Now crystallization is used to separate a dissolved solid from a solution when the solid is much more soluble in hot solvent than in cold. So when we are talking about crystallization, basically in this case we are talking about a dissolved solid. We are separating a dissolved solid and a soluble solid from that solution, and the solid is mainly much more soluble in hot solvent than in cold. For example, we are going to discuss that. That's, if you take an example, that will be copper sulfate from a solution of copper 2 sulfate in water. So I'm separating, in this case I'm separating copper sulfate that's a dissolved solid, from the solution of the copper to sulfate and water. Now, what is the technique? The solution is heated, allowing the solvent to evaporate to leave a saturated solution behind. Okay, so you can see here a diagrammatic representation that flame is causing that solution to be heated, and when the solution is heated, that will allow the solvent to evaporate to leave a saturated solution behind. Now we have a test for that, a particular test for that, that if the solution is saturated or not. What we'll do, we'll dip a clean, dry, cold glass rod into the solution, and if the solution is saturated, the crystals will form on the glass rod, and this will give us an indication that the solution is saturated. Now the saturated solution will be allowed to cool slowly, and the solids will come out of the solution as the solubility decreases and the crystals will grow. Okay, now what will happen? This solution will be allowed to cool slowly, and the solids, you can see here the crystallized solute, the solids are coming out of the solution as the solubility decreases and the crystals will grow. And what will happen then? These crystals will be collected by filtering the solution. The filtration process will come then. So in crystallization, you have two processes: crystallization and then filtration. And they are then, the crystals basically are then washed with cold distilled water to remove impurities and allowed to dry. So this is the whole process of crystallization. So let me just recap what we have done in crystallization is that this technique is used to separate two soluble solids from a solution, given that they have different solubilities. It works by dissolving the two solids in minimal water and then slowly cooling it. The less soluble solid crystallize first. Okay, so this is the overall technique. Moving on to simple distillation. Now, where we were discussing the referring of the fractionating column, there are two methods, and we are using a fractionating column, and that's simple distillation and fractional distillation. Now, what is simple distillation? Now, simple distillation, this is a method that is used to separate a volatile liquid. Volatile liquid means that it is easy to evaporate from a solution with a non-volatile liquid that's not easy to evaporate. Non-volatile solid, sorry. For example, salt water can be purified using this method. Okay. Now, it's used to separate a liquid and a soluble solid from a solution. Example, water from a solution of salt water. So basically, from water, from that liquid, I'm separating a soluble solid. That soluble solid in this case is my salt water, and the liquid in this case is my water, or a pure liquid from a mixture of liquids. We can also say that. What happens? Firstly, the solution is heated and the pure water will evaporate, producing a vapor which rises through the neck of the round bottom flask. Let me just show you a diagrammatic snapshot of that. So what is happening? We are passing the flame. You can see here at the bottom, we are passing the heat. And what's happening? The solution is being heated and the pure water vapor, you can see the pure water vapor that's evaporating and going up the round bottom flask. The temperature is increasing. Okay, producing a vapor which rises through the neck of the round bottom flask. Now what will happen? This vapor of that pure water will pass through the condenser. Now condenser is a place where it will cool, where the vapor will cool and will condense. It will turn, meaning it will turn back into the pure liquid, pure water, H2O, which is collected in the beaker. So in this case we have the condenser. The pure water vapor, the water vapor is passing through the condenser and it's getting cooled and condensed into the beaker and being collected, and that pure water we are just being collected in the beaker. Now what happens? After all the water is evaporated from the solution, only the solid solute, in that case my salt water, that's I'm separating that salt water from that water, so in that case my salt gets left behind. That salt crystals, you can see that salt crystals will be left behind in the round bottom flask, and your pure water vapor, your pure water gets collected in the beaker. Moving on to fractional distillation. Now what is fractional distillation? What is this method? We should know about that. So fractional distillation, this is a method that is used to separate the different liquids from a liquid mixture. So we are separating two or more liquids that are miscible with one another. Remember, immiscible and miscible you already know that you might be already knowing that they have opposite definitions. If immiscible means that they cannot mix with each other, then miscible means obviously that it can mix with each other. For example, ethanol and water from the mixture of two. In this case, we are talking about that. Okay. For example, we can also discuss for example, a mixture of water and ethanol can be separated using this method. Okay, so fractional distillation works by using the fact that different liquids have different boiling points. It is a bit more complicated than simple distillation, but here is how it works. Okay, so we already know that the fractional distillation is a method that is used to separate two or more liquids that are miscible with another, that can mix with each other. Example, we have ethanol and water from the mixture of both. Okay, so what will happen? The solution is heated to the temperature of the substance with the lowest boiling point. Okay, so I will be giving you examples at the last after we are done with the process. Okay, so what will happen? So the solution will be heated to the temperature of the substance with the lowest boiling point. So here you can see the diagrammatic snapshot that I have a diagram here. The apparatus is arranged and the fractionating column, everything is arranged. What is happening here? So in the round bottom flask, I have my water and ethanol solution. So firstly, the solution will be heated, the mixture will be heated to the temperature of the substance with the lowest boiling point. Okay, so firstly I am heating up to the 78 Celsius temperature. All right, that's the lowest boiling point, and that's for ethanol molecule, because water has the boiling point of 100 degrees Celsius. Now what happens? This ethanol molecule, the pure ethanol vapor, will rise through the fractionating column. And what will happen then? Let's see. And vapors will pass through a condenser. The process is, at this point, the process is similar to the simple distillation. Now it is passing to the condenser where they cool and condense, turning into a liquid that will be collected in a beaker. And this process will be repeating until we get all the pure ethanol collected in this particular beaker. In the, you can see by the gray color, it's a peach color. Yeah. Now all of the substance is evaporated and collected, leaving behind the other components of the mixture. Now for water and ethanol has a boiling point of 78 degrees Celsius and water of 100 degrees Celsius. The mixture is heated until it reaches 78 degrees Celsius, at which point the ethanol boils and distills out of the mixture and condenses it into the beaker. When the temperature starts to increase to 100 Celsius, you should immediately stop the heating. Why we should stop the heating? Because now what will happen? Your water, like this means all of the pure ethanol has been collected, has been separated, has been finished off from that mixture, and now only the liquid that is left behind, that's water. So we have separated both of them. Now for the sake of argument, let's say the round flask contains a mixture of liquid A. Okay, this same flask is containing a mixture of liquid A. That's boiling point. Let's say it has a boiling point of 50 degrees Celsius, and we have a liquid B in the same mixture and boiling point of 100 degrees Celsius. So what will happen? As you heat the flask with the Bunsen burner, the temperature of the flask and the fractionating column will begin to rise. It is really important to understand here that the bottom of the long column is always going to be hotter than at the top. So what's happening here? You can see the fractionating column. If I just zoom in, the bottom part of the fractionating column will be more hotter than the part that is at the top. All right, this is simply because we are heating from the bottom and it takes time for the heat to rise up. That's why. That's a simple fact. So let's imagine the round flask hits 50 Celsius. What do you think will happen? Okay, so what gonna we visualize? I have given you the examples. So let's say let's visualize the round flask hits 50 degrees Celsius. Now what will happen? The similar thing will happen to as ethanol. We are discussing that's liquid A in that case. So liquid A will start to boil in the flask, but the vapor won't get far in the column before cooling back down into the liquid, back into the flask. This is because of the temperature gradient in the column. Now the very bottom of the column might be 50 Celsius, but the top will be cooler than that, meaning the gas will just condense back to a liquid before reaching the top. Therefore, the main point to take away here is the gas can only go up as far as the temperature in the column allows it to. Okay, because what happens, because of the temperature gradient, because of the temperature difference in the fractionating column, at the bottom we have the 50 Celsius, but it might be cooler on the upwards. Okay, so eventually, however, the column will heat up sufficiently. When the top of the column reaches 50 Celsius, at that point, the vapor of liquid A will reach all the way to the top and get condensed into liquid by the condenser. So it's important for the fractionating column to get overall heated to 50 degrees Celsius. All right. So then your your pure liquid A vapor will be get collected into the beaker by passing through the condenser and cooling down and being condensed into the beaker and getting separated. So once all of the liquid A has entered the flask, we simply need to replace it with an empty one. Alright, so we have collected all our pure liquid A in one beaker. Now what we can do, we can replace it with an empty, so we can just collect our another liquid that's left behind. Now the column will then continue to heat up. Eventually, okay, the top of the column will hit 100 degrees Celsius. Alright, so at that point, that's the boiling point of liquid B. Alright, and it will reach the top of the column and become liquefied by the condenser. It will turn into a liquid by the condenser and then into our empty flask. By utilizing the different boiling points of liquid A and liquid B, we have successfully separated it from the original mixture. Alright, and that's it for today. This is the end of the lesson, and um, we have covered all the concepts of the chapter of experimental techniques, and later videos we are going to discuss about the atoms, elements and compounds. That would be a lot fun. Yeah, so it's a bit lengthy, but I will make sure that we cover it in a bit on time. So that's it for today. We have discovered many new concepts. I hope this video was useful for you. So if it was useful for you, make sure you comment down below. You can ask me questions in the comments section, and please don't forget to like the video, hit the subscribe button, share with your fellow classmates, and stay tuned for my upcoming videos. Take care. Have a good day.